Okay, let's get started. Today we're doing a deep dive into, well, a really surprising link. It connects something you might be wrestling with in math class calculus, actually with farming, agriculture.
That's right. Our sources look at how these mathematical tools get used, out in the real world on the farm. And we're zoning in on one specific thing, integration.
Integration, yeah. The calculus kind.
Exactly. It's being used to figure out the total water intake of livestock. Think cattle, sheep, specifically when they're grazing on irrigated land.
Right. It sounds super specific, maybe even a bit niche. But our mission here, really, is to show you how these concepts you might be learning, differentiation, integration, all that stuff, they aren't just stuck in textbooks. They're practical tools, powerful ones.
Absolutely. I mean, if you're a college student staring at integral signs and thinking, when am I ever going to use this?
Right.
Well, here you go. This is a perfect concrete example. It shows how this math actually gets applied.
Okay, so let's dig into this specific scenario then. Livestock, irrigated fields, drinking water. Why calculus? Why do we need integration to figure out the total amount they drank? Couldn't you just, time one cow for an hour and multiply?
That's a great question. And it really gets to the core of why integration is the right tool here. See, water intake isn't a flat, constant rate. It varies a lot.
Based on what?
Oh, loads of things. Ambient temperature is a big one. Animals drink way more when it's hot, obviously.
Makes sense.
Also, time of day, what they're eating, the type of forage, how active they are, even just differences between individual animal. It's happening continuously while they graze, sure, but the rate they drink at, that's changing all the time.
Okay. So a simple average just won't cut it, because if the rate is jumping up and down, an average would just smooth it all out, lose the detail.
Precisely. An average gives you a ballpark figure, maybe, but it won't be truly accurate. Integration is designed for this. It's the mathematical way to add up something that's changing continuously over an interval, whether that interval is time, like here, or distance, or area or volume and other problems.
Right.
So by integrating that changing rate of water intake over the whole time the animals are on that patch of land, you get a much, much more accurate total volume.
Right, that clicks from the math side. But why does agriculture need that level of precision for water intake? What's the actual, real world point?
Yeah, good question. This is where it gets really valuable for farm management. Knowing that accurate total is key for using resources efficiently, especially on irrigated land.
How so?
Well, think about irrigation. If you put too much water on, it's wasteful. It can wash away soil nutrients, cause runoff pollution. But if you don't put enough water on, you stress the plants, the pasture, and you stress the animals too. So by knowing precisely how much water the animals are actually taking directly from water sources on that land, it helps farmers make much smarter decisions about their irrigation. When to water, how much the pasture itself needs.
I see. So it's not just about counting the animals' drinks. It's about understanding the whole water picture for that piece of land. Like water in from irrigation, water used by plants, water drunk by animals, getting the balance right.
Exactly that. It's about the overall water balance. And that precision really supports sustainable practices. It means better water demand forecasts, using limited water resources more effectively. It can even impact animal health.
By making sure they're properly hydrated.
Yep, especially during heat waves or other critical times. Getting that number right using calculus informs big operational decisions, financial ones too, on a modern farm.
Wow. So finding the area under a curve essentially translates into better farming. Healthier soil, healthier animals. Okay, so let's try and summarize this.
Right. The core idea, integration, is this powerful way to sum up a process accurately, even when its rate is constantly changing.
And this deep dive gave us a really specific, tangible use case, calculating the total water livestock drink on irrigated land, accounting for all those fluctuations.
Yeah, it really shows that these math concepts, differentiation and integration, aren't just abstract theory. They have real practical value. They help quantify the world, sometimes in places you wouldn't expect, like, a pasture full of cows.
Absolutely. So here's a final thought, something for you to consider. Where else might the fundamental math you're learning, or maybe learned years ago, be the key to solving some practical problem that we haven't even thought about yet?